Welcome to my presentation. In this presentation, we shall try to solve simple examples using the laws of exponents. So let's take an example, and in this example we want to simplify this example. In this example it states open parenthesis minus x y to the power of 4 z to the power of 3. This whole thing is raised to the power of 4. So the way we want to solve these examples is by applying some of the laws of exponents which look very similar to this. So as a solution, we will break it down into these different steps and then write them out in a systematic manner. So the property we want to recall, or the law of exponents we want to recall, is this, isn't it? If we have two terms, x times y, and if this is raised to the power of m, every one of the terms inside the parentheses will be raised to the same power. So we can write this as x to the power of m times y to the power of m, and that is the law. That is one of the laws of exponents. We will apply that concept to this particular example which we are looking at. So we have open parenthesis negative x y to the power of 4 z to the power of 3. This whole thing is raised to the power of 4, and the way we can write this one out is the negative sign is raised to the power of 4, x is raised to the power of 4, y to the power of 4 is raised to another power 4, and then z to the power of 3 is raised to the power of 4. So in here we want to simplify all of these terms, and the way to do that is as follows. Negative raised to the power of 4, we can write that as negative raised to the power of 4 simplifies to negative times negative times negative times negative. The negative is the base term, 4 is the exponential term. The number of times the base term needs to be repeated is 4 times, so therefore we did that. So negative times negative is a positive, negative times negative is a positive, so therefore positive times positive is a positive. So therefore negative raised to the power of 4 is a positive quantity, so we established that. And then x to the power of 4 is x to the power of 4, and then y to the power of 4 raised to the power of 4, we can write the base ones and then multiply the powers. So in my step 3 we can write it this way now. The negative raised to the power of 4 is a positive, so we can write the positive, and then we have x to the power of 4, nothing changes there. And then in y to the power of 4, the whole thing raised to the power of 4, we're going to write the base, and then we're going to multiply the powers, 4 times 4, and then we're going to take the last term, which is z to the power of 3, the whole thing raised to the power of 4. Since an exponent is raised to another exponent, we're going to multiply the exponents, z to the power of 3 times 4. That is the way we want to write it out. Therefore, we can simplify this as x to the power of 4, that means positive x to the power of 4. The positive signs are implied. If we do not write it, the positive signs are implied. We can write this as x to the power of 4 times y to the power of 4 times 4 is 16, and then z to the power of 3 times 4 is 12. So the answer is x to the power of 4, y to the power of 16, and z to the power of 12. So this is where we want to leave it. The given expression, open parenthesis negative x y to the power of 4 z to the power of 3, the whole thing raised to the power of 4, simplifies to x to the power of 4, y to the power of 16, z to the power of 12. So that is the way we want to use the laws of exponents to simplify this example. Let's see if we can apply these laws of exponents to solve this next example. In this next example, we want to simplify this expression, a to the power of 6 divided by a to the power of 4. Okay, so let us see if we can recall one of the laws of exponents to simplify this problem. So what we have is, in the laws one of the laws we had was, if we had x to the power of m, and in the denominator we had x to the power of n, since we can write this as x to the power of m. The numerator exponential part we can write it as is. The denominator part, x to the power of n, we can write it as x to the power of negative n. When we bring a positive exponent to the numerator part of it, we can express that as a negative exponent. X to the power of positive n becomes x to the power of negative n when we bring it up to the numerator. So therefore, since the bases are the same, we can write the base once and then we can combine the powers. Combining is m minus n. So x to the power of m, x to the power of n m divided by x to the power of n, we can write as x to the power of m minus n. So therefore, in step 2, we're going to apply this rule and then simplify the given problem. We have a to the power of 6 divided by a to the power of 4. So therefore, we can write this one as a to the power of 6 times a to the power of negative 4. The positive exponent, we can express it as a negative exponent, bringing up into the numerator. Therefore, since the bases are the same, we can combine the powers. 6 minus 4. And we can write this as, we can simplify this some more as a to the power of 2. Therefore, this is where we want to leave it. This is our answer. So an expression a to the power of 6 divided by a to the power of 4, when we use the laws of exponents, we were able to simplify it to this form, which is a to the power of 2. This is the way we want to use the laws of exponents to simplify these types of example problems. In my next presentation, we shall look at some more examples and see how we can solve those examples using the laws of exponents.